Welcome to NX for Manufacturing Tech Tips. Today's tech tip is an introduction to the new milling enhancements in NX85 CAM. We're here today with Jim Heers, and Jim's going to be doing the demonstration today. Welcome, Jim.
Thank you, Aaron. Okay, so a little bit about what I was going to cover today is I'm going to show just a very brief showing the 2.5D volume milling as been introduced recently in 8.5, and then there's a separate tech tip out there just on this subject, so I will keep that one fairly short and not do a whole lot of in that on this session today, but invite you to go out and find the demo of the video of the tech tip for this. Then I'm going to show a little bit of rest milling with flow cut and cutting corners using a reference tool. We'll run through that and actually create an operation. Then we're also going to go off and do some contour profiling. Contour profile has been around a while, but we're actually going to show the introduction of the that is new, the ring height adjustment, where you can control which portion of the tool is cutting as you're profiling. And then I'll finish it up with some 3 to 5 axis tool tilt, and we've got a nice little presentation on that one also. So with that, we'll jump right off into the demo.
Okay, I can see your screen, Jim.
Okay, thank you. Let me let the messages go away now that I have it. Okay, so first thing I'm going to do is I've already opened up a part, and I want to go create the new floor wall milling type operations. And so what I'm going to do here is come down through here, tell it right away it displays me the stock that is available to be cut. I can come in, tell it I want to cut these floors, pick multiple floors if I want, and when I generate, it'll actually generate the toolpath for it. And very quickly I can get feedback to see what that toolpath looks like. Now, if I don't like the way this looks in here, it's fairly easy at that point to come back, tell it I want to change the profile of that, and tell it to follow the part. So now we'll go look, and we'll do it one more time with the 3D material removal so we can actually see the material being removed. Now we'll get a much better finish there as we can see what the part's going to look like. Okay. Then second operation I'll create on this part is I'm going to do the same type of operation. Come over here. I'm going to tell it the floor. I want to cut this other floor that I missed on the first one. And now I've got my floor for it. And if I wanted to look at the resultant workpiece of that, here's what it's going to look like. And I probably should not spin that around because I know that doesn't look good in the graphics window when I do that too much. Okay, so the second thing I want to do is I'll go ahead and flip this over, and let's go ahead and do the other side of this part. And same thing, we'll create an operation. And again, I can pick multiple floor heights if I want. I'll tell that to follow the part instead of a zig. And we will create the tool paths on it. So very quickly and easily you can create these volume metric tool paths. And this is introduced, it's really to help with the creation of tool paths on 2.5D. So you're actually not actually doing 3-axis machining on these type of tool paths. Okay? And like I said, there is a separate video out there with tech tips just on these type operations, and I invite you to go out and review that. Okay. The next subject I wanted to move to is we're going to talk about the rest milling, and basically the rest milling is cutting the corners that are left over when you use a tool that is too big to finish the part. An example being I've already got a cavity mill operation in here that is basically roughing the part. Then I do a contour profile with a 4mm ball end mill to cut the part to near size. Then what I want to do is now cut these corners along that were left over. So I'm going to go ahead and create an operation that is going to be a mill contour. We're going to do a flow cut with a reference tool. This means that we're going to flow along those corners, and we will tell it which size tool that we used to cut it originally. So I'm going to grab my 2mm ball end mill. My cut area, I want to specify where on the part I want to cut, and then I'm just going to drag a box around the cut area. We'll come into our flow cut drive methods here. I want my hookup distance. This is the distance that on where it will actually look to hook up a similar type of operations. And then down here, I also want this step over. I'm going to change it over. And then here's where I need to tell it my reference tool. When I machined this my previous operation, I had this 4mm ball end mill, and I need to specify that. Okay, with that, let's go ahead and generate a tool path. So right away, it knew, based on that, where we had cut with the 4mm ball end mill. Now we're coming in with this 2mm ball, and we're going to profile the corners. And we've got mixed operation type, tool path types, to where depending on whether it's a steep or whether it's non-steep, we will get different directions of cut. And I'll show that here in just one moment once it finishes figuring it out. Something, I think, guys. I'm going to have to back up one step. And, oh, here's where I went wrong. This was set at 10% of the tool. I'm sorry, I wanted to go 0.3mm. What I did not do was change from percent of my tool. But it was fairly quick for me to go figure out what my problem was when I saw I had way too many passes to cut that part. And so now it's going back and it'll calculate the tool paths here. But I knew that I had way too much time there. So if we zoom up on this, this is what I was talking about. You'll notice as we're cutting the non-steep areas, we're going back and forth across the part. Now as we're doing the steep, we're doing zigzag up and down. And so now let's go verify those, or look at the verification on those tool paths. And I'm going to slow that guy down a bit. And so we'll go play that tool path. You can see it's actually zigzagging back and forth down along that corner, and it's going to whittle these out. But then when it's going along the horizontal surfaces, it's actually profile back and forth, zigzagging that direction. Big improvement in the surface finish and being able to control your tool. Give it lots of control on that. Okay, so there is that operation. I will go ahead and if we wanted to verify this whole process, we could actually, if we wanted to look at the resultant 3D, we could see that on this part, and it will show us what the part looks like based on the current cuts. And we can kind of see I hadn't actually finished this area up here, but then you can kind of see the tool paths down there. So okay, the next one I want to cover is I'm going to move off into our contour profile. Contour profile has been around for several versions of NX, but what I want to show you today is the creating an operation and then controlling the ring height for the finish of it. So typically when we would machine these in the past, we would actually use a ball end mill, and if you come in with just a ball, let me replay this and just kind of show you. typical tool path that you'd do in the past was you'd machine this something like this with just a ball end mill. The time to do that is actually quite a bit longer. And so what we're going to do is we're going to use a contour profile operation. Contour profile allows us to simply specify the floor. It will automatically determine walls for us, and it knows that this is our wall. And then we can actually contour that wall with the side of the tool, similar to swarf cutting it, as opposed to just using the ball end mill. One of the advantages of doing that is the time required for this type of operation is much shorter. Okay, so the one thing that is the improvement here was in the past, if we had left this set to none and generated that tool path, that would be the type of operation that would have resulted. But what we have available today is being able to go control that and tell it what the ring height on the tool is. Let me go back in there one moment. So when I look at this ring height, so yeah, we had the option of none, constant, or variable, and I'm going to use variables this morning. Next thing I want to do is I want to come into my cutting parameters, multiple passes. I want multiple depths of cut. We're going to tell it this is 28 millimeters, the total depth, and I want 7 passes. And we'll go ahead and generate an operation for this. And so if we go look at the verify on this type of tool path, we will actually get a much better finish using the side of the tool, and plus it's much faster than using the ball end mill that we would have seen originally. And if you look at this finish, it's better than if we did not have that ring height set and we left this set to none. We generate that. This, you'll notice a difference, and I'm going to zoom up on that area here in just a moment once it finishes that. So let's zoom up here. We look at the tool path here. And you'll notice there will be definite steps where you step over, and it's already visible here. So your finish is reflecting the steps in this. That's why you would want to use that variable ring height so that you can eliminate these steps in here and get a much better finish. Okay, so that's the result there. Here was one with the variable. Let's go ahead and refresh, and if I just show the workpiece, the finished resultant workpiece here, you'll notice that that does not have the steps in it. Okay, so big improvement in the way that your finished operations and what they're going to look like as you machine the part. Okay, the last operation that I wanted to go and work on today is the 3 to 5 axis tilting. What this is designed for is for you to be able to create a tool path in a 3-axis format. So what I have currently, I've already generated this tool path. If we go look at this, and I just look at some points, you'll notice with a short tool holder, we're colliding over here in the corners. Or also, if I come over, sorry, let me get all the way down here. So if we come over here, we're colliding with the clamps also. That is very undesirable. It's kind of detrimental to your machine tool life. But the advantage, we want to use a short tool to make it more rigid. So what we'll do here is tilt this toolpath. And it's very easy to program, just the flat 3-axis toolpath. Then I can come over here on my toolpath and say I want to tilt it. Let me turn the lock off first. And so we'll say tilt. Now, here are some of the parameters that we get when we're going to tilt this tool. We're saying we want to fan 30% of the tool distance. The max tilt is going to be 45 degrees, so I don't want to go beyond 45. And I want to clear my holder by 100 thousandths down here. And I want to make sure I always clear my shank by 30 thousandths, or the neck also. Neck I'm not worried about because this tool doesn't have one. So I'll say OK to this. This toolpath that was already created that quickly, I now have a 5-axis toolpath. And if you notice, we are now tilted enough to clear the clamps, so the holder is not colliding with the clamps. And as we get over here into the corners, it's tilting both directions away from the part there also. Let me slow this guy down a bit. Let's let it run through just a little bit. What I want to do is let it kind of go just enough that you can see. Once it gets out into the part, it stood back up. So we're back to a 3-axis toolpath that does not have to be tilted, because you don't have any clearance issues there. And so we've actually now went from the 5-axis back to simply cutting a 3-axis toolpath, which, less motion with the machine. And to take this a step further, if you've got your full machine kinematics in here and you want to simulate that full machine kinematics, that's set up, this 3 to 5-axis toolpath can be simulated. And so what I'm actually going to do is I'm going to go full screen so I get a little more graphics area here. And let's go ahead and run that. And so now you can see we've got the full kinematics available, and being able to see that toolpath being machined. And note that we are clearing the clamps and the walls now with our tool holder. And again, I was not going to let that run all the way through. I'll let it run just a couple of minutes here just to show you that it knows to move all around and clear those. It's aware of where the part is. And then as it comes around, it will stand the tool up more because it doesn't have to have it tilted over as far, and it will eventually come back to where it's simply a 3-axis toolpath once it's clear. And there it's now back to just simply standing it up.
Great, Jim.